Coulomb's law. In previous movie, we saw that Q1 and Q2, if they were two charges and they had opposite signs, they attract one another. So Q2 exerts a force on Q1, F2 on 1, and Q1 on 2, F1 on 2. When those charges had equal sign, like two negative charges, they repel one another. When they were both positive, the same, they repelled one another. So F2 on 2 on 1 in this direction, F1 on 2 in that direction. Now Coulomb investigated the situation. First he had two same charges, which have forces 2 on 1 in this direction, F1 on 2 in this direction, and then investigated the influence of the distance. He put them further apart, and the forces became smaller. When they were smaller, they were not just smaller, they had direct proportion, so F was proportional to the inverse of the distance squared. And then he put them at the same distance as the beginning, but he made, for in this example, Q2 larger than Q1. And both forces became larger, which is quite logical, because if Q2 is larger, because he is larger, he will pull harder on Q1. But because he is larger, Q1 will be harder pulled upon by Q2. So we can say that the force is proportional to both charges. Now we put that in a formula, so we have our situation here. We just name now 2 on 1 2 and 1 on 2 1, and this is Coulomb's law. This is the same with the proportions, but now we need of course a constant, so F1 equals F2, absolute value. Because the sign we will deduct from the situation and a drawing. It's better to just work with the absolute values. So F1 is F2 is K, these are constants, times Q1 times Q2 divided by R squared. And the K is 8.99 times 10 to the 9th power Newton meter squared divided by Coulomb squared, which is of course dependent on medium, but we will only work with this for the moment. Let's see that in an example. We have a positive charge of 60 nanocoulombs is located at a distance of 2.0 centimeters from a negative charge of minus 30 nanocoulombs. Calculate the magnitude of the force the two charges exert on one another. Given is this situation, we have Q1 and Q2. They exert a force on one another. Their distance is 2.0 centimeters. Q1 is 60 nanocoulombs, Q2 minus 30 nanocoulombs. We have to find the force, and the solution is of course using Coulomb's law, which is given here again. We fill everything in we know, which makes the K is 8.99 times 10 to the 9th. Q1 60 times 10 to the minus 9th Coulomb, nano is 10 to the minus 9, and 30 times 10 to the minus 9th Coulomb. We divide it by R squared, which is 2.0 times 10 to the minus 2 meters, centimeters, and that of course is squared. Don't forget the second bar here, the square, because that's a mistake pupils often make. And when we put this all on our calculator, we find that we have a force of 0.040 Newton. Okay, now it's best up to you to make some exercises.